We now determine the absolute extrema of this given function f of x equals x raised to the power of 2 thirds in the interval -3 comma -1. So the first step in determining the absolute extrema is to find the critical points of the function. So first we find the critical points. We can find the critical points of the function by setting up the first derivative equals 0. That is, when f prime of x equals 0, and then we solve for x from this equation, we get the critical points. So let's do that first. I'm going to find the derivative of this function f of x. So I write down f prime of x, and this equals, we can apply the power rule of differentiation. So we put the power in front 2 thirds and raise x to the power of 2 thirds minus 1. So this equals 2 thirds x raised to the power of 2 thirds minus 1, and this equals 2 thirds minus 3 thirds, and which equals 2 minus 3 is -1 thirds. So this is basically -1 thirds, and in fact we can rewrite this as 2 by 3 times of x raised to the power of 1 thirds. So since we have to set up this f prime of x equals 0, we set this expression, that is 2 thirds x power 1 by 3 equals 0. So when we put this, we get 2 thirds x raised to the power of 1 third equal to 0. So this is a rational fraction, and any rational function a fraction becomes 0 only when the denominator is a large quantity, that is when it approaches infinity. So clearly x raised to the power 1 third, only when it approaches infinity, this complete fraction becomes 0. However, in the given interval, this infinity is a very large quantity, and it is not lying within this interval. So we can say that there is no critical point to this function. However, we can still look out for the absolute extrema, that is absolute maximum or absolute minimum within this interval. For that, we create a table, that is x versus f of x, and then we put the endpoints. The endpoints are -3 comma -1. So I put the endpoints over here, -3 comma -1, and I determine the corresponding function value at x equal to -3 and x equal to -1. So we know that our function is f of x equals x raised to the power of 2 thirds. Now let's plug in x equal to -3 into this. So we get f of -3, and this equals -3 raised to the power of 2 thirds. We can rewrite this as -3 raised to the power of 2, and then once again raise it to the power of 1 third. So it's basically -3 quantity square, which is 9, and raised to the power of 1 by 3. So when we plug this into the calculator, we approximately get the value as 2.08. So therefore the function value at x equal to -3 is 2.08. And similarly, we determine the corresponding function value when x equal to -1. That is, we find f of -1, and this equals -1 raised to the power of 2 thirds. Once again, we can rewrite this as -1 raised to the power of 2 and raised to the power of 1 third. -1 raised to the power of 2 is -1 quantity square, which is positive 1, and positive 1 raised to the power of 1 by 3 is 1. So you can say that the function value at x equal to -1 is positive 1. And clearly we can see that this is the lowest in this interval, lowest value, and this is the maximum value. Since we don't have any critical number, these two values becomes the one of them becomes, this is the absolute minimum. This is absolute minimum, and this is absolute maximum. So we write the coordinates of the absolute maximum, that is absolute maximum, we write down in coordinate form as x is -3. The corresponding function value is 2.08. And then we say that absolute minimum, this is -1 comma 1. And so these are the absolute extrema of the given function. We now determine the absolute extrema of this given function f of x equals sin x plus cos x within the interval 0 to 2 pi. So first, let's determine the critical point of this function. The critical point of the function occurs at the first derivative equals 0. So first, let's find the derivative of this function by differentiating both sides with respect to x. So we get f prime of x equals the derivative of sin x is cos x, and the derivative of cos x is negative sin x. Now we set this up equal to 0 so that we can determine the critical points. So when we set this up equal to 0, this becomes 0 equals cos x minus of sin x. Now I add sin x on both sides. So we get the equation sin x equals cos x. So we can determine from the unit circle sin x equals cos x or cos x equal to sin x only when x equals pi by 4, as well as when x equal to 5 pi by 4. We can see this diagrammatically. So if you consider this as a unit circle, and this is x equal to pi by 4, this angle is x equal to pi by 4, and this complete angle is 5 pi by 4. So at these 2 points, both the sin x and cos x are equal. That is, the coordinate is this is root 2 over 2, comma root 2 over 2. Both are positive. Sin pi by 4 is root 2 over 2, and cos pi by 4 is also root 2 over 2. And similarly, when x equal to 5 pi by 4, the coordinate is negative root 2 over 2, comma negative root 2 over 2. Both values are negative. That is, sin pi by 4 is negative root 2 over 2, and cos pi by 4 is negative root 2 over 2. So we have determined that there are two critical points, that is x equal to pi by 4 and x equal to 5 pi by 4. Now to determine the absolute extrema, we have to create the table. So let's create the table with the endpoints as well as with the critical points. So I put x over here, and we determine the corresponding the function value f of x. So first, let's start off with the lowest value, that is 0, and then the next is pi by 4. Then the next value of x is we use this 5 pi by 4, and finally we put the the endpoint, that is 2 pi. So we have to calculate the corresponding values of this table by substituting into the function. We know that we have been given the function f of x equals sin x plus cos x. This is our original function. Now we take this endpoint and plug it into the function. So it becomes f of 0 equals sin 0 plus cos 0. Sin 0 is 0 and cos 0 is 1. So 0 plus 1 is 1. So the value of this function is 1. Now let's plug in x equal to pi by 4. That is one of the critical point. So it becomes f of pi by 4, and this equals sine of pi by 4 plus cos pi by 4. Sine pi by 4 is root 2 over 2, and similarly cos pi by 4 is root 2 over 2. So this is basically root 2 plus root 2 is 2 times of root 2 over 2. So we get root 2. This is a positive quantity. We put this as root 2. And now find when x equal to 5 pi by 4, we determine the function value. So it is f of 5 pi by 4, and this equals sine 5 pi by 4 plus cos 5 pi by 4. We already determined that sine pi by 4 is negative root 2 over 2. This is from the unit circle. And similarly, cos pi by 4 is also negative root 2 over 2. So when we add this, we get a negative 2 times of root 2 over 2, which equals negative root 2. Now let's put this into the table. So this is negative root 2. And finally, we determine the function value when x equal to 2 pi. So therefore, we find f of 2 pi. This equals sine of 2 pi plus cos of 2 pi. Sine 2 pi is 0 and cos 2 pi is 1. So therefore it is 0 plus 1 equals 0. So once again we get the function value as 1. And clearly from this table, in fact, we can approximate this root 2 so that we can easily determine the maximum and the minimum of this value. This is approximately 1.414. And similarly, this negative root 2 is negative of 1.414. Now we have to compare the table values, that is 1, this value as well as negative 1.414 and as well as 1. Out of these four values, this positive value, that is 1.414, is the maximum, which means the absolute maxima occurs at when x equal to pi by 4. So we can say that the absolute maxima of this function, this occurs at pi by 4 comma root 2, or we can write down this in decimal as pi by 4 comma positive 1.414. And similarly, if you look at the table, this negative 1.414 is the lowest of all these four values. So this is the absolute minima of the function, and this occurs at x equals 5 pi by 4. So we say that absolute minimum, the coordinate of absolute minimum is 5 pi by 4 comma negative root 2, or we can represent this negative root 2 in decimals as 5 pi by 4 comma negative 1.414. So these are the coordinates of the absolute maximum and absolute minimum.